Hello. So in this video, we are going to cover some rules for calculating probabilities of multiple events. If multiple things are occurring simultaneously, there's some simple rules that allow us to calculate those probabilities. So the first idea is of independent events, events that don't affect each other. The probability of one effect doesn't change whether the other outcome has occurred. So a very simple example would be, I got to mute my video now. Here we go. Very simple example is if you flip a coin twice. Two times. You could say event A is flipping heads on first flip. B is flipping heads on the second flip. So what's the chance of getting two heads in a row? So probability of A and B, what's that? So since these events are independent, it doesn't matter if I get a head on the first flip, whether I'll get a head or a tail on the second flip. We call these independent events. And the rule says, if I want to know the probability of both occurring, I just multiply the individual probabilities. So this probability of flipping heads twice is the probability of a head on the first flip and a probability of a head on the second flip. And both those are 1/2. So the probability of getting two heads is 1/4. It's a very simple example of independent events. So let's look at something a little more complicated. Say you got a brewery that uses 2 bottling machines. You know, in case one of them fails, they got to have the backup. So they operate this, they don't go at the same time. We only are using one at a time. And so the first machine is a little bit newer. It is known to break down only 20% of the time. So what this means is 20% of the time it's broken. Or broken, it's not working right. Okay, but the second one doesn't have as good of a rate. The second one, if the first one breaks down, they turn on the second one and it breaks down 30% of the time. So this is kind of important to know, what's the chance that both are not working? Probably that neither of the systems brewing are broken. So let's call A the event that the first one is broken. And let's call B the event that the second one is broken. So probability of A is 0.2. There's a 20% chance of it breaking. Probability of B is 0.3. So this question is saying, what's the probability that both of them are broken? Oh, well, that's just probability of A. If they're independent, times probability of B. So 0.2 times 0.3, which is 0.06. So there's a 6% chance of both being broken. Okay, so that's direct application of this multiplication rule here, the first rule for independent events. So now, what if we want to know the reliability of this operating system? Like, what's the reliability, which is the chance that something is working? So reliability is when both are working. Or I should say the chance that both are working. The probability that both are working. So notice if A and B is when they're both broken, the reliability is the complement of that. Okay, so the probability of A and B not working using our previous rule of complementary events is the probability of A and B, 1 minus the probability. That's 1 minus 0.06. So we got a 0.94, 94% reliability. So this is the rule of complements that we used earlier. If you need some review, which we wrote like this: P of A complement equals 1 minus P of A. Well, notice my whole event here is A and B occurring. So if I look at the complement of that, it's 1 minus. Okay, so that's my first rule. You can use that in a lot of interesting cases. The second rule is for events that might not be independent, or when multiple events occur and you're interested in either one of occurring. So here the question is, we're flipping a coin and rolling a dice, 2 events. We could call the coin A, the dice B, and we want to know the probability of getting a head. Okay, we'll call that our event A. And getting a 6 on the dice B. So we want probability of A or B. All we care is if I get a head or if I get a 6. Maybe there's some kind of reward for some game that we've made up. So one way we can do this is we can list all the outcomes. 1, 2, 3, 4, 5, 6 for heads, 1, 2, 3, 4, 5, 6 for tails. And so notice out of the 12 outcomes, 6 of them, probability of heads is 6 out of 12. There's these 6 out of the 12 that have heads. Yeah, so what about this? How many outcomes have a 6? Notice this one is a 6 and this one is 6. So 2 outcomes have a 6. So the probability of getting a 6 is 2 out of 12. Okay, so if we think maybe we can just add these together, probability of A plus probability of B, and I guess I'm calling A heads and B 6. 6 out of 12 plus 2 out of 12, that's 8 out of 12. But wait, how many outcomes are either a head or a 6? Satisfy that condition. Okay, let's go back to green. Notice this has a head, this has a head or a 6, this has a head or a 6, this one, this one, this one, and this one. So how many outcomes either have a head or a 6? There's 7 outcomes. So probability of head or 6 really is 7 out of 12. Notice that's kind of different than what we found here if we just add them. So what we did, there's a problem in this calculation over here, is we overcounted. We overcounted on this guy, right? We've counted him twice. So that's the probability of getting a head and a 6. Head and 6 in this case is 1/12, which you could also find as probability of head times probability of 6, which is 1/2 times 1/6. Kind of side note. But anyhow, this is the guy we've overcounted for. So the real rule, the way we have to fix this equation over here on the right-hand side, is we have to subtract the way we've overcounted. Probability of A and B, probability of head and 6. So if we minus that 1/12, then we get the correct answer, 7/12. And so here is that rule for calculating events that occur simultaneously. Probability of A or B is you add the 2 probabilities, but you have to minus, this is like the intersection when both occur. So that's a nice example. I'll give you one more example to do together. Let's do this one. I draw 2 cards from the deck. What's the probability of getting a club or a face card? Two cards in the deck. I'm gonna make this 1 card. Yeah. I want to make this as simple as possible. If we draw 1 card of the deck, what's the probability of getting a club or a face card? Okay, so using our rule of 2 events, that's the probability of club plus probability of face card, or notice the word or. Then we have to minus the probability of club and face card. Okay, so how many cards in the deck are clubs? Probability of club would be there's 13 clubs out of 52 cards. How many face cards are in our deck? There's king, jack, queen, king. So that's 3 per suit, and there's 4 suits: clubs, hearts, diamonds, spades. So that's 12 out of 52. Okay, but how many of these are both clubs and face cards? You could have the jack of clubs, the queen of clubs, the king of clubs. So that's 3 out of 52. So probably getting a club or a face card on that card is 13 plus 12 minus 3. So 22 out of 52. Okay. Yeah. So I'm going to leave this question like this for the quiz. And I'm going to go on to the last rule. The last rule is if 2 events cannot occur at the same time. Here's the definition of mutually exclusive. If they cannot occur at the same time, they're mutually exclusive events. And another way of saying that is the probability of both of them occurring is 0. So if they're mutually exclusive, we can take our previous rule, probability of A or B, equals probability of A plus probability of B minus probability of A and B. Well, if this thing is 0, we just can get rid of that term. So it gives us a slightly simpler rule. So an example of how this is applied is, what if I'm rolling a dice, a 6-sided die, and I want to know the probability of rolling an even number? So that's like saying probability of A, or I'll say it this way, probability of 2 or 4 or 6. That's the same as saying the probability of 2 plus the probability of 4 plus the probability of 6. We're applying this rule for 3 events now. Since you can't get a 2 and a 4 at the same time, or 4 and a 6 at the same time, we can just add the probabilities. So that's 1 out of 6 plus 1 out of 6 plus 1 out of 6. So 3 out of 6 or 1/2. So this is a kind of an intuitive rule, but it helps to distinguish what kind of event we have. Are they independent or not? Or are they mutually exclusive? This all affects how we can calculate probabilities. All right, so that's all for this video. Good luck on the quiz, and we'll see you in class.